Now, we will get a good image of it when it comes close to Mars on October 3rd. We don't need to wait a lot. So we should be able to tell how much light is reflected off the object and from that infer its size.
In October 2025, something flashed across the skies of Mars. Too fast, too straight, and too precise to be a meteor. Within minutes, every Mars orbiter went dark, and NASA's live feeds froze mid-transmission.
Oh, nice.
Yes, look at that bad boy.
This is a raw image.
When data from the 3I Atlas flyby finally resurfaced, the images revealed something we've never seen before. The flash over Mars, an interstellar streak. On October 2nd, 2025, Mars became the center of an unexpected mystery. A thin white streak appeared in one of NASA's nightly observation recordings. It was fast, straight, and impossibly precise.
At a velocity of about 135,000 miles per hour, so it's going really fast. For that distance from the sun, this is really exceptional.
For less than a second, it cut across the stars above the Martian horizon, the faint boundary where Mars's surface meets the blackness of space, and then disappeared completely. At that time, Perseverance, NASA's robotic rover exploring the Martian surface, was performing a standard night sky observation. The rover's panoramic cameras are usually used to check how dust in Mars's thin atmosphere affects light from the stars. These nightly recordings are calm and predictable. But that night, when the images were reviewed at NASA's data center, one frame immediately stood out. A clear white line stretched across the darkness.
It is only the third time we have detected an object that has come from beyond our solar system.
It was too sharp to be caused by dust, too steady to be a passing particle, and too defined to be a camera error. The team compared the next frames, expecting the line to vanish. Instead, it reappeared, moving slightly across the image, but keeping a perfectly straight path. Someone decided to check its movement against the known positions of stars in that part of the sky. The results shocked everyone. The object responsible for the streak appeared to be moving at nearly 60 kilometers per second. That speed is far beyond anything natural that Mars could produce. Typical meteors entering the planet's thin atmosphere move much slower, and orbiting satellites do not leave such trails. The only objects known to move that fast are those that travel through the solar system from deep space. When the team compared its direction with astronomical charts, it aligned almost exactly with the predicted course of a recently identified interstellar visitor known as 3I Atlas. A few hours later, several Mars orbiters that had been programmed to capture the flyby stopped sending live data.
This object has just been discovered. 3I Atlas was discovered on July 1st by the NASA-funded Atlas survey.
Engineers blamed a data backlog, meaning the spacecraft were online but had suddenly stopped transmitting new images or measurements. Still, the timing raised concerns. The blackout began only minutes after the strange streak appeared in the rover's feed. When the orbiters came back online, the expected images were missing. There were no files, no readings, and no explanation for the interruption. The official report included a single sentence: observation postponed pending review. For many inside NASA, it felt like a polite way of saying something had gone wrong. Inside the control room, the atmosphere grew uneasy. Analysts who reviewed the footage later said that what unsettled them most was not the streak itself, but the absence of data surrounding it. Every second of the recording was accounted for except the instant when the light appeared. That single moment became the foundation of a mystery that would soon spread far beyond Mars. To understand how this story began to evolve, we need to meet the man who independently verified the signal in the public archive and refused to let it be ignored. The amateur astronomer who caught it. In a quiet suburb of Arizona, amateur astronomer Stephen Burns spent most of his nights alone in a small backyard observatory filled with computer screens, telescopes, and cables.
That they will take observations of interstellar object 3I Atlas with.
For years, he had followed every public data release from NASA's Mars missions. His passion was studying raw images. the unedited snapshots captured by the Perseverance rover to track faint objects that professional surveys might overlook. NASA's raw image data from Mars usually takes a few days to appear in public archives. So when Burns downloaded the latest batch on October 5, 2025, it included the material captured 3 nights earlier, the same session in which Perseverance had recorded the mysterious streak already under review by NASA analysts. He began his usual process of sorting and stacking the images to filter out dust interference and camera noise. The streak that NASA's own teams had identified was now visible in his local copy of the data. Burns did not make a new discovery. Instead, he verified that the same anomaly appeared in the public frames exactly as NASA's internal reports described.
3I Atlas as taken from Mars. It performed a close approach.
Using his digital sky mapping software, he checked the alignment against known star coordinates. The object's movement matched NASA's earlier trajectory models, cutting smoothly across the background stars without deviation. To confirm the source, Burns examined the pixel data and found that the light intensity remained uniform from frame to frame, proving that the signal came from an external origin rather than a sensor fault. When he calculated its apparent velocity, his results aligned almost perfectly with the agency's own data, about 60 kilometers per second, matching the predicted path of 3I Atlas during its close pass by Mars. What NASA had already detected, Burns now confirmed independently. According to online forum posts later that night, Burns initially thought it was a coincidence, but after several cross-checks, the pattern held. He prepared a short report describing his method, the star alignment, the timestamp verification, and the motion analysis, then uploaded both his results and the raw images to a small astronomy forum.
We'll pick out objects that are moving inside of the 4 frames, and we have to identify if they are real or if they are false detections.
Finally, he posted his findings online and invited anyone to test his process. Replication and rivalry in the data hunt. When Stephen Burns released his findings, the response was immediate and explosive. Across the world, hundreds of amateur astronomers, data analysts, and image specialists began downloading the same Perseverance raw frames that he had analyzed. Some did it out of curiosity, others to prove him wrong, and a few simply wanted to be the first to confirm a discovery that could make history.
We've only discovered less than 40% of the 90% of the object we need to discover.
Within hours, data servers hosting the Mars image archives slowed under heavy traffic. People everywhere began to run their own analyses, stacking the frames, adjusting filters, and checking the timestamps. At first, the results seemed straightforward. Several users confirmed the same linear streak exactly where Burns had marked it. They verified the same trajectory and the same frame-to-frame consistency. For them, this was proof that the signal was real, but not everyone agreed. Other analysts, using different calibration settings, claimed they saw nothing at all.
From images, we also saw that this object is active, which is an indication that this object is in fact a comet.
Some said the streak vanished when they adjusted the color balance or changed the noise filters. The situation grew more confusing when a small research group in Canada reported something even stranger. In their composite animation, a faint green flash appeared in one of the stacked frames at exactly 0003 UTC. The discovery set off a storm of debate. On technical forums, one side argued that the green light was simply a product of overprocessing, the kind of digital artifact that appears when too many images are layered together. The opposing side insisted the flash was genuine, possibly the result of a chemical emission or an unknown radiation burst. The conversation quickly turned emotional. Posts were deleted. Accusations of manipulation began to fly. By the second day, online communities had fractured into camps. Every variable became a new battleground. Noise filters, brightness thresholds, stacking algorithms, even monitor calibration. Arguments that started as scientific soon turned personal. Some users accused others of attention-seeking, while a few suggested that the flash might have been deliberately removed from the original archives. That rumor gained traction when users noticed that NASA's official telemetry files, which normally remained visible alongside the images, had quietly disappeared from public access. No announcement explained the removal. For many, this was the final spark that turned collaboration into rivalry.
Could seed life across galaxies, will disappear behind the sun, and will again emerge in November 2025.
What began as a joint investigation now felt like a race, one that mixed science, pride, and suspicion. Each group wanted to be the first to declare the truth about what Perseverance had seen over Mars. The chaos continued with no clear resolution. The data was real, but no one could agree on what it meant. And while the world argued, Mars had already fallen silent. The orbiters sent to watch 3I Atlas were still running, but their signals began to fade, one by one, as if something out there did not want to be seen. The orbital campaign that vanished. Before the flyby, the world's top space agencies had prepared an ambitious plan. 3 orbiters circling Mars were programmed to observe the passage of 3I Atlas from different vantage points. NASA's Mars Reconnaissance Orbiter with its high-rise camera, the European Space Agency's Trace Gas Orbiter carrying Cassis, and Mars Express with its HRSC imaging system were all part of a synchronized campaign.
9 smaller glowing objects moving in perfect formation with Atlas, as if it were leading a convoy.
Each spacecraft had been carefully calibrated to track a fast-moving object like 3I Atlas, traveling nearly 9 million kilometers away, something no Mars mission had ever attempted before. The engineers who worked on the observation described the coordination as one of the most delicate operations ever planned for interplanetary imaging. The exposure schedules were mapped to the second. Any deviation, even by a fraction, could cause the cameras to miss the object entirely. To make sure everything was ready, simulation runs were carried out in the days leading up to the flyby. Every command had to be executed precisely, and every frame mattered. When the moment finally came, the team expected a steady stream of high-resolution images. These pictures would have provided the first close-range visual record of an interstellar visitor passing Mars. But days passed, and no data appeared. Normally, even unprocessed raw frames are uploaded to public archives within 72 hours. This time, nothing arrived. Speculation spread quickly. Some believed the data was delayed because the images showed something unexpected. Others suspected technical failure. A few claimed it was deliberate censorship. Whatever the reason, the result was the same.
It will be closest on October 3rd, and spacecraft in orbit and on the surface will try to catch a glimpse.
The first interstellar observation campaign around Mars had gone completely dark. Behind those official statements, however, engineers were facing a nightmare that few outside the mission control rooms would ever understand. Inside the calibration bottleneck. Inside mission control, frustration replaced excitement. Tracking an interstellar object from Mars was proving far more difficult than imaging a crater or a mountain ridge. Craters do not move. They sit still, waiting for light to hit them. But 3I Atlas was different. It was traveling at 60 kilometers per second, moving across the Martian sky faster than any camera sequence had ever been programmed to follow. Every frame had to be perfect. A single misalignment could create a false signal.
It is only the 3rd time we have detected an object that has come from beyond our solar system.
Cosmic rays, solar particles, or even digital noise could mimic movement. Engineers called it a race against error. They knew that if even one image showed an unexplained streak, public speculation would spiral out of control. The team had already seen what happened online when Burns shared his discovery. They could not afford to release data that might be misunderstood or misused. To avoid that risk, the imaging teams began an exhausting manual review. Each photo from the orbiters was analyzed frame by frame. Technicians zoomed in on individual pixels, searching for signs of distortion. They realigned every capture, checking whether stars stayed fixed in place between exposures. If a bright spot appeared, they ran multiple tests to confirm whether it was a real object or a cosmic ray hitting the sensor. The process was slow and tense. According to internal sources, the calibration team had to rework their entire data processing pipeline. Normal automatic correction tools were not enough. The object's extreme speed and distance required them to rebuild algorithms to handle motion blur and fluctuating light intensity.
These aren't faint smudges caused by optical distortion or lens artifact moving together through the void between worlds.
Every possible cause of interference, from temperature variation to electronic noise, had to be ruled out one by one. Hours passed, and still, no public images were released. Engineers privately admitted they were afraid of misinterpretation. A streak could be mistaken for a companion object. A blur could look like a shadow or a structure. The risk was not just technical, but reputational. If the public believed that NASA or ESA had found something unnatural, the agencies would face a wave of questions they were not prepared to answer. Outside the labs, however, patience was running out. Online forums filled with anger. Commenters accused the agencies of hiding evidence. Journalists demanded statements. The longer the silence lasted, the more the world became convinced that something was being covered up. Inside the control rooms, the scientists worked through exhaustion, driven by caution rather than secrecy. But even their careful precision could not prepare them for what came next. The problem was no longer just in the images, it was in the signals themselves. Data that once flowed smoothly between Mars and Earth began to flicker, as if something was interfering with communication. And that was when the silence started. The silence between signals. The first signs of trouble had already appeared on October 2nd, 2025, minutes after the flash streaked across the Martian sky. Several orbiters suddenly stopped sending data, and the interruption was brushed off as a temporary backlog. Engineers believed it was nothing serious, just an automated pause while the system switched channels. But when the spacecraft resumed transmission, the missing frames were never recovered. That single blackout became the quiet warning of what was still to come. In the following days, as scientists prepared for the official flyby of 3I Atlas, the carefully timed observation campaign in which multiple Mars orbiters would track the object as it passed near the planet, the problem resurfaced. Communication between the orbiters and Earth had been stable for months, yet now the signals began to flicker. At first, it looked like routine interference from solar radiation or deep space static. But soon, the timing of each dropout became too precise to ignore. Each interruption lasted only seconds. Data streams from multiple spacecraft, Mars Reconnaissance Orbiter, Trace Gas Orbiter, and Mars Express, cut off almost at the same instant, then resumed together as if coordinated. The first event was recorded as a calibration lapse. When it happened again 2 hours later, and again the next night, the pattern could no longer be dismissed as coincidence. During every blackout, receivers on Earth picked up a faint narrowband radio pulse near 1.4 gigahertz, the hydrogen line. Space agencies and city researchers call this frequency the universal channel because hydrogen fills the universe and would be a logical choice for interstellar communication. The realization unsettled even veteran engineers. Mission Control worked to keep the situation calm. Official reports blamed the interruptions on cross-channel reflections caused by the object's position near the Sun.
We'll pick out objects that are moving inside of the 4 frames, and we have to identify if they are real or if they are false detections.
Yet several technicians noticed that the bursts were not random static. They repeated in a clear rhythm: short, long, short, short. When plotted on a timing graph, the intervals resembled code. Internal emails soon passed between ESA and JPL teams. One message, later leaked, mentioned possible signal contamination originating near the target object. Another warned that public release could cause unnecessary speculation. Soon after, all logs referring to the dropouts were rewritten. Instead of signal loss, the database displayed a new phrase: instrument silence. The term confused many. It was not standard language and replaced normal error codes without explanation. Some insiders suspected it had been added to conceal what was really happening. Outside analysts noticed the change and began asking questions. If this was merely solar interference, why were the interruptions so regular? Why did they occur only when 3I Atlas crossed the same region of the sky? By the second week of October, the dropouts had become rhythmic and predictable. Private observatories began detecting faint static bursts during the same time window, and a few amateur radio astronomers claimed to record them, describing the pattern as heartbeat-like. The agencies offered no public comment, but inside Mission Control, tension grew. Engineers privately admitted the signals did not resemble random noise or system failure. Whatever caused them followed a rhythm that matched the trajectory of 3I Atlas itself.
We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth.
If these interruptions were truly random, they would have stopped. Instead, they pulsed, steady, deliberate, and beyond explanation. And when the long-delayed images finally reached Earth, what they showed made scientists' heads spin and left everyone else wondering if something out there had just answered back. What the flyby images were hiding. The images, gathered by Mars's orbiters and quietly processed inside research centers, showed details that no one was prepared to explain. Once the noise was removed and the brightness corrected, analysts began to notice something that froze the room. Around the solid core of the object, faint glimmers of light appeared, small reflections forming a near-perfect ring. They were evenly spaced and symmetrical. Frame after frame, the same reflections appeared, moving in harmony with the main body. They neither scattered nor drifted. Each stayed in formation, as if connected by an invisible structure. When the sequence was slowed, the reflections turned ever so slightly, catching light in timed rhythm. Some experts compared them to panels rotating around a central frame. Others argued they resembled containment braces, a pattern that suggested design rather than accident. Whatever it was, it looked deliberate. The next wave of data deepened the confusion. Instruments detected clouds of metallic vapor near the object, nickel, cobalt, and a trace of something that dissolved before it could be catalogued. 3 separate sensors recorded the same reaction. As sunlight hit the object, it released particles that disintegrated in seconds. At first, scientists blamed calibration errors, but when the same results appeared in backup instruments, those excuses collapsed. Something around 3I Atlas was changing on a chemical level.
It will be closest on October 3rd, and spacecraft in orbit and on the surface will try to catch a glimpse.
Reacting violently to light. Inside Mission Control, a split began to form. A small group of analysts proposed what later became known as the containment theory. According to internal notes, they believed the object was not a comet at all, but a vessel, one carrying unstable compounds that could not survive exposure to solar radiation. If true, the glowing vapors were not natural emissions, but warning signs of decay. Others in the team called the idea absurd. They insisted the readings could still be explained by rare mineral chemistry or camera interference. Yet, even those skeptics admitted that nothing about the object's behavior matched any known cometary model. As the arguments spread, fear took hold. Some researchers, speaking anonymously, warned that 3I Atlas might be shedding dangerous materials, possibly radioactive or corrosive elements unknown to human science. They worried that if fragments entered a planet's atmosphere, the chemical reaction could be catastrophic. Others dismissed such claims as sensational. They argued that even if the object carried exotic elements, the distances involved made any risk negligible. The divide between those two camps widened by the hour, turning scientific discussion into quiet panic. The object's stability only made the situation worse. Despite its enormous mass, estimated at more than 10 billion tons, it moved through space with complete precision. There were no visible jets, no spin drift, and no gravitational wobble. Natural objects, even large ones, always show small instabilities. 3I Atlas showed none. It behaved as though it were balanced by design.
It is only the third time we have detected an object that has come from beyond our solar system.
A state of equilibrium so perfect that some began calling it unnatural. Then came the final image before the blackout. In it, a burst of green light flared around the object, expanding in a perfect sphere before fading into darkness. The light lasted less than a second, but the frame captured its shape clearly. A hollow wave spreading outward like gas venting through cracks. Engineers called it a discharge. Others whispered that it looked like a rupture, as if something inside had broken free. As 3I Atlas began moving closer to solar conjunction, communication delays started. For now, the blackouts lasted hours or a full day, and they were expected to grow longer as the object passed behind the sun near the end of October. Inside research forums and encrypted chat rooms, theories multiplied. Some believed it would reappear unchanged once geometry allowed observations again. Others feared it might not reappear at all, and that whatever was inside it was now drifting free. By mid-October 2025, the debate was no longer about what the object was, but what it meant. To some, 3I Atlas represented a relic of alien engineering, evidence that intelligent life had passed this way long before humanity learned to look up. To others, it was a warning, a decaying fragment of something that should have stayed far from any living world. If the first interstellar visitor carried something unstable, then Mars did not just witness a flyby. It may have witnessed the first sign of a threat that science is not ready to confront. Whatever truth lies behind the missing frames, one fact remains certain. 3I Atlas came and left without explanation, and the silence it left behind feels less like an ending and more like a warning. And if what passed over Mars was not a comet, but a message, what was it trying to tell us? Do you think 3I Atlas was natural or something far more deliberate? Share your theory in the comments below.